From Theory of Computation and Compiler Design.
வினைத்திப்பம் என்பதொருவன் மனத்திப்பம் மட்டைய எல்லாம் பிற
Important data structure created and maintained by compilers is symbol table. Symbol table can store information about the variable names, function names, objects, classes, interfaces, etc. It is used by analysis part as well as by the synthesis parts of a compiler. We need to know, what is quadruple representation? It is a type of 3 code representations. 3 address code is a type of intermediate code which is easy to create and can be easily converted to machine codes. The compiler chooses the order of operation passed by the 3 address codes. Quadruple representation expression is divided into 4 parts that are 1. Op field stores the internal code of the operator. 2. arg1 stores the first operand. 3. arg2 stores the second operand. 4. Res result field stores the result of the expression. Four options were given. 1. Constant folding. 2. Induction variable. 3. Strength reduction. 4. Code reduction. What are they? That is the question. These are the compiler code optimization techniques. In the given code fragment 4 into 2.1, 4 can be evaluated at compile time and replaced with the constant 8.56. This is known as constant folding and it is part of compiler code optimization techniques. Exclusive video on compiler code optimization techniques is available. Same is given in I button. Shift-reduce parser constructs the parse tree similar to bottom-up parsing, for example constructing from leaves bottom to the root up. This shift-reduce parser requires two data structures that are 1. An input buffer for storing the input string, 2. A stack for storing and accessing the production rules. In the given regular expression a star b, open bracket a plus b close, this implies as follows: first one, a star is 0 or more times a, second one, b means 1 time b, third one is a plus b means a or b. From this question what we need to understand is that it is asked just to find the minimum finite automata, so it's about finding minimum NFA only and not the minimum DFA. Hence we are going to draw the state diagram for minimum NFA. This question is on closure properties of languages. We need to know some points from the closure properties of languages before answering this question that are given as 5 points. First one is complement of a recursive language is also recursive. Second is recursive language union by REL, that is recursive enumerable language will give a recursive enumerable language. Third is complement of a CFL is a recursive language. Fourth one is recursive language union by recursive language results in recursive language because recursive language is closed under operation union. And finally, clean closure of regular language is regular intersection regular language with CFL will give CFL. The closure properties of languages table is available in my Webster, same is given in description, you can verify. Question is to find the given CFL is finite or not. Properties to decide CFL is finite are 1. No loops allowed, 2. No repeat, no redundancy allowed, 3. Need to ensure non-empty, no null string. Option A has redundant CFG, hence it is false. Option B is non-redundant CFG but null strings were not removed, hence it is false. Option C is non-redundant CFGL with set difference of null strings, non-redundancy and non-empty strings are ensured in option C only. we need to know the properties of the recursive language. Thumb rule is that recursive languages are accepted by any Turing machine and halts on any input string. We have 4 options that are: Option 1, input string belongs to L. Then M accepts input string and M will not halt, hence it is false, RL will halt. Option 2, input string not belongs to L. Then M accepts input string and M will halt by reaching at final state. When input string does not belongs to L, it will not accept the string and it won't reach the final state, hence it is false. Option 3, input string not belongs to L. Then M halts without reaching to acceptable state. When input string does not belongs to L, it halts and it will not reach the acceptable state, hence it is true. Option 4, input string belongs to L. Then M halts without reaching to an acceptable state. When input string belongs to L, it will reach the acceptable state, hence it is false.